So question 4, the last question on tutorial sheet 8, saying a block of mass 5 kilograms is on a ram inclined at theta is equal to 25 degrees to the horizontal. The coefficient of kinetic friction is 0.28. So that's the diagram. Then there are questions that follow. Question A, draw the free body diagram. Question B, calculate the value of the net force. And C, calculate the value of the frictional force. And D, find the acceleration of the system and tension in the rope. Okay, so how are we going to come up with our free body diagrams here? So we have two objects. There's one that is inclined like that. Okay, and we know to say there is weight acting down there. But since there's a theta here of 25 degrees, hope theta is 25. Okay, theta is 25 and there's 5 kilograms times 25. Okay, so we have to resolve our forces. So we're going to have our mg cos theta here and our mg sin theta at that side, like that. Then we have a rope here, which means there's tension pointing in that direction. And since it's standing on a surface, there's a normal force here. So those are the forces that are acting on the 5 kilogram object. This is the 5 kg object. And this object only has two forces, we have mg here and the tension that is in the rope here. So since these guys are accelerating towards the left, we can say to say we have negative forces here. Oh, I forgot one force on this diagram. They mentioned to say there is friction. Let me just put it in here. There's also a frictional force. Okay, so these are the forces. So we know to say these forces that are opposing motion or they're acting in the opposite direction to the direction of acceleration, they'll be negative. So we have those two forces and also this force, which is here, the tension, is pointing up. Then this one, which is here, and the tension, which is there, these guys, they should be positive because they are along the direction of our acceleration. So those are the free body diagrams for our system. And question A is saying, draw the free body. Okay, we've already done that. B, calculate the value of the normal force. Okay, so the normal force is in the y-axis. And the y-axis has how many forces? It has mg cos theta and fn. And since there's no acceleration in the y-axis, that means the two objects are at equilibrium. So we're going to say fn, which is the normal force, is equal to what? It's equal to mg cos theta, like that. So Fn, which is the normal force, will be equal to 5 kilograms multiplied by 9.81 cos 25 degrees. That is going to give me 5 multiplied by 9.81 multiplied by 9.81 cos 25. Okay, so this is giving me a normal force Fn of 44.45 Newton. So that is the normal force according to what we have on our diagram. Then our mg cos theta, our normal force is 44.45 newtons. Question C is saying calculate the value of the frictional force. So frictional force is due to the normal force, and do not say friction is equal to the coefficient of friction, which in this case it's kinetic friction, multiplied by the normal force, which is Fn. So this will be equal to what? They've already given us the coefficient of friction to say it is 0.28. So 0.28 multiplied by 4.45. We are going to get 12.45 Newton as the value of our frictional force. Okay, so if that is the frictional force, find the acceleration of the system and tension in the rod. So this question is solved enough now, which I don't expect anyone to have difficulty. So we said on the object that is hanging freely, we said there are only two forces. There is tension, which is opposing the motion, and the mg, which is in along the direction of acceleration. We're going to say summation of forces in the y will be equal to what? Will be equal to mass times the acceleration. And what forces do we have in the y? We have mg minus, since tension is a negative force, so we have mg minus t. This is equal to mass times the acceleration. So this is the 20 kilogram object. So I'll say 20 multiplied by 9.81 minus t. This is equal to 20 multiplied by a, like that. So 20 multiplied by 9.1, 196.2 t. This is equal to 20 a, like that. So this is for the object that is hanging freely, and I can say this is my equation 1. Then I go back to my object, which is on the incline. And what forces do I have? I have tension here, I have mg sine theta there, and I have friction, which means I have three forces there. I'll say my summation of forces in the x for the 5 kilogram object will be equal to what? Will be equal to mass multiplied by acceleration. So what forces do I have? I have tension, which is positive, minus friction, minus mg sine theta, and this will be equal to mass multiplied by acceleration. Tension minus, what is the value of friction? Friction is equal to just 12.45 tons, 12.45 newtons, minus mg sine theta. So mg sine theta will be equal to what? Will be equal to 5 multiplied by 9.81 sine 25. This is 20.73 minus 20.73. This is equal to 5a, like that. So t minus 20, 12.45, 45. That's 33.17. So minus 33.18. This is equal to 5a. And this will be my equation 2. So if I have these two equations, you can see we're missing the same thing, which is tension and the acceleration. So we can actually just solve them as a system of simultaneous equations. So I'll say t here is equal to 5a plus 33.18. I'll get this and replace it into equation 1, where there's t. So 196.2, 196.2 minus t is what? 5a plus 33.18. That is equal to what? It is equal to 20a. That is equal to 20a, like that. So 196.2 minus 5a minus 33.18. This will be equal to 20a, like that. So 196.2 minus 33.18 is giving me 163.02 minus, so this is equal to 20A plus 5A by 3. So 163.02 will be equal to 25A. So I divide both sides by 25, then this side by 25. I'll get my acceleration is equal to 6.52 meters per second squared, like this. Okay, so that means that's value for acceleration. So I can look at acceleration and plug it into this formula for us to get the tension. So say T is equal to 5A plus 33.18. So T will be equal to 6.52 plus 33.18. So this is 32 plus 33.18. We're getting tension is equal to 65.784 Newton. All right, so that was the last question in tutorial 8. Thank you very much. We have calculated the acceleration of 6.52 meters per second squared, plus the tension in the string is 65.784 newtons. So that marks the end of tutorial 8. And thank you very much for your time. Thank you for watching. Let's continue this academic journey together. And you can actually like, comment, share, and subscribe to the channel. Thank you very much, guys.